So let's do a little bit more of a little more complicated example. We have about 20 minutes. I'm going to try to do this one right as well. And that way, if we don't get to the last example, we're not really missing out on anything. Or actually, no, I think we'll just follow along the way this is. So let's look at, we give you this file, by the way, so you don't have to do this one. You don't have to write this one down. It's here, right? Lecture05, surface and area. This is the code that we're talking about, so you don't have to take notes here, or you don't have to write down the code as you take notes. We'll just kind of pop this into Python Tutor, I think. Okay, so we've told you that we want to start using our math functions, especially because we want to use math.py. It's more accurate than having to remember 3.14159 every time, or we get more digits anyway. So we'll start off with our import statement. That should generally be, your import should go at or near the top of your function. And what we want to illustrate with this is I kind of showed you a straight line with the main calling the function, or the print statement calling the function, but it was kind of a linear call of the function we defined by a specific part in the main. And what we want to illustrate here is that it can be more complicated than that. In particular, we can have our def area of circle, which I should have kept. Area circle, radius, and our colon, and we have our indent, and we're just going to return. I'm going to be a little bit more concise this time because I'm still on notes. That should have gone that time. All right, well, it's there now. Okay, so we have our import at the top of the file. We have our definition, area, circle, radius. We have our math import there. So we will use our value of pi, math.py, times the radius squared, right? So we'll return mathpy.radius squared. So we can write our area circle function rather concisely in only one line. Just the expression that's going to get returned is, I think we had this divided up into 3 lines before, but we'll just kind of condense it there. That's good. And now what we want to do is we want to have a second function. This is the area of the circle. The second function is going to be the surface area of a cylinder. So we will do def area cylinder. And that's going to have 2 parameters. It's going to have a radius, and it's going to have a height, right? Because a cylinder has a radius and a height. And we'll indent again. And now what we're going to do is we want the surface area of the cylinder. And we wrote this before in one of our earlier examples without using functions. But if we remember, the area of the cylinder is right. The area of the cylinder is the area. So the surface area of the cylinder is, you take the top and bottom caps, right? And those are circles with radius. And then you take this side piece, and you can consider this side piece, if you just cut down and unwrap that side piece, right? The length is going to be the circumference of the circle, and the width is going to be the height. So the area of this right, this is the base area. So the area, the surface area of the cylinder is 2 times the base area, which is this, plus the circumference of the base area, 2 pi r, times this height. Right? So we're just going to implement that for the base of, for the surface area of the cylinder. And when we do that, we're going to use the fact that we can calculate the circle area using our area circle. So we'll have circle area equals area circle, our function call. Yep, of course, that one won't go. Okay, you are back again. So circle area, right, our local variable is going to be the area of the circle. And it's going to have the radius of the cylinder. The height area, the area of that rectangular section, is going to be 2 times the radius, right? This is the circumference of that of the base area, that's what we just talked about, times math.pi. And then we have to multiply that by the height to get the area of that rectangular section, times height. And now we can return 2 times the circle area, right? The top and the bottom caps of our cylinder, plus the height area. Okay. And now I'm going to kind of, having fumbled through typing that in and it looks correct, I'm going to kind of steal the testing code. Okay. And what we're going to find out is we're going to print out, we're just going to test our area circle function once. We'll write out the rounded area circle 2 decimal places for value 1, so that should be 3.14. And then we'll call our area cylinder with a radius of 2 and a height of 10. So let's visualize this execution. Let's see what happens. And this is used for debugging code apparently, but I only use it for illustration. So we'll import math. You'll see that what happens is all of the symbols from math get pulled in on that import, and they get stored away as a module instance object. So we have access to all of the math stuff now. We see the definition of the area circle, but we don't do anything. We just make a note of it. We know where it is. We know what its parameters are. We see the definition of the area cylinder. Again, we don't do anything. We just make a note of it. We know where it is. We know what its parameters are. And now we're actually into the body of the main code, and we reach our first executable line, which is print the area of circle radius 1 is, and then that makes a call to our area of circle call. Right? So this print can't be completed without making this call, and then, by the way, a call to round. So we will pop in, we'll come up to our area circle. The parameter radius gets replaced by the argument 1, and there are no other lines, so we just kind of return the results of this expression right back to the calling line. Right, so we're going to return 3.14159 and so on. These are rounded to 4 decimal places, and that gets put into here. The round call gets made. You don't see that because we don't have that loaded in here, but the round call gets made, and we do our printout of the area of a circle of radius 1 is 3.14. Okay, so we saw that we can call area of circle from our main just like we could before. Now we'll set up some parameters in the global scope. Right, we're going to set up our parameter r, or I'm sorry, our variable r, set it to 2. Our variable height, set it to 10. This first print can execute. Right, we have all the data we need including that R. So the first thing that'll come out is the line, the surface area of a cylinder with radius 2, right? Because we can execute this. Now we hit return again accidentally. I guess I can go back one. Okay. Right, so we print this out. Now we try to execute this next line, but in order to execute it, we have to hit this area of cylinder call. So we'll pop through. We know we're calling area of cylinder from this position on this line. So we take R. R becomes the formal parameter radius. We take height. Height becomes height, right? So now we have two variables, height, in our program. This value masks this value. They're two separate variables, right? They live in two different places. This masks this until we come out of the area of cylinder, while we're within the body in this indented part for area cylinder, this height will mask this height. All right, so we come down in. The first line in area cylinder can't be completed without calling area circle. So what we'll see is now we'll pop up to area of circle. So now we have area circle pushed onto our stack as a separate stack frame. It has a radius 2. Area cylinder has a radius 2. Again, so long as we're within the body of area circle, this radius masks this radius. Doesn't matter so much since they're both the same value, but that is the case, and we could actually change radius in here and it would have no effect on area cylinder. We step down through, we calculate our 12.5664, and we return it. And this time, because we were called by area cylinder, we return to area cylinder. We don't go back to main. So circle area now has the value we returned. We calculate height area. All the data is there. Height, radius, math.pi from the math function, math module. We can calculate the height area, and now we calculate the overall surface area of the cylinder and return that back, which gets put in right here, and we print out our 150.8 value. Okay, so that's a little bit more of a more complicated version. Let me come in here for just a second and illustrate something that I just said. If we come in here and I say height equals 9,000, let's visualize that. What I want you to see is this idea that what the masking actually means. So we come down here, height equals, our radius is 2, height is 10. We print out the area of a cylinder with radius 2. And now we're at our call to area cylinder. And height gets height, radius gets 2, circle area gets area circle, right? That should be our 12.5664. We calculate our height area. Height is 10, height is 10. We overwrite height with 9,000, right? If we were to print out height at this point, it would be 9,000, but we haven't changed the height in the main program. We just can't see that one. And now when we return this time, when we pop all that data from this area cylinder off of our stack frame, we're right back and we have our old value of height. So we haven't actually changed the value that we were looking for. And this becomes really important when we're looking at things like lists and aliasing and things like that. But you have to understand the behavior, pretty much right at this point. All right. I think we've got about 4 minutes. So I'll do what I normally do. I'm going to go through. I want to finish, kind of. I'm not going to be able to do as many of these as I'd like. I'll try to hit those at the start of the next lecture. But I do want to talk about program structure, and then I'll stick around and answer some questions. So I told you that we're going to do some stuff on program structure. And I said that we want it to look something like this. I'm going to edit this code, Control C. Let's pop this down into a new. The first thing we want is we want this, a description of what you're doing. So we're going to do write functions to calculate the surface area of a cylinder and provide testing code. Okay, so the first thing we would want to do is we'd want something that tells us what this file actually does. Then we have our imports. Then we have all of our function definitions. So there are two function definitions. And when we write our function definitions, actually I think we want to go we will want to, wow, Kite does this for you. We'll want to come in and we'll want to describe our parameters. Actually, this is a float, can be a float. Returns. Just for homeworks, lecture exercises, we don't look at this. Will have to be looked at manually by the TAs. So the question was, is this just for homeworks or for lecture exercises as well? So this would be area of the base, and this would be a float. So the idea is you just come through here and you fill out. This is more formal than I would normally do it. But it just, when I did that, it just gave it to me. So I took it. I think that's because I have Kite installed. And then we would do the same thing for area of cylinder, right? The parameters, the return types, the values. Now we're down to the body of our program. And that would be the fourth thing in our file. We'll kind of expand on this as we go along. We'll tell you, that you should put your inputs, any questions you're asking, to the extent you can. Questions you're asking the user up front, early. So we have a little bit more. We'll keep expanding on this as we go along. But this is a good first start, and this should get you through, essentially your first homework. I think at this point we are out of time. I've got a little bit left to do, but actually not as much as I was afraid of. So we'll touch on this briefly at the start of the next class. And why don't you go off and have a good day. And if there's any questions, I'll stick around for a little bit. I do have to go back and re-record that first little section. Ugh.